I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover the Secure Settings Option Application activity. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally, that you've completed the Requirements Taxonomy, Security Requirements, Secure Design Principles, Apply Secure Design, Secure Settings Overview, Secure Settings Identify Options, Secure Settings Categorize Options, and Secure Settings Select Options trainings. This training will cover the Secure Settings Option Application activity. Before getting into Option Application, let's briefly review where it fits in the overall Secure Settings process. Here's the Secure Settings process which we previously covered in the Secure Settings Overview. Our focus for this training is going to be on the fourth activity, that of Option Application. Within the Option Application activity, the DevOps SME takes the element-specific tool security document from the Option Selection activity and the build file and applies the security options to the appropriate elements section, creating an updated build file and generating a Security Options Application report. Now let's work our way through an example of the tool's cybersecurity relevant option application. We'll be working with the element-specific tool cybersecurity options document created in the option selection activity. It's important to note here that this is just one mechanism for documenting this information. There are any number of ways the information could be documented. In an ideal world, you'd use a database to store the information both across tools and versions of tools and aligned with each element. If a database is used, the information needed by the DevOps SME should be exported into a flattened representation. Here are the options from the element-specific tool cybersecurity options document. The part that we need to make sure that the DevOps SME gets are just the first three columns: the option ID, the option, and the disposition. We don't need the justification or notes fields. It might be useful to sort this based on the disposition and then the option, but it's an individual preference. You could simply provide the elements that are to be included, but if you want to make sure that the ones that you wanted to be excluded aren't already turned on, then having both is useful. I'm not going to go into build system specifics here, and the fact that we're talking about these options going into the build file does not preclude them from going into the settings of a standalone tool being used within the context of the build system. There are going to be some tools, static analyzers are a good example, which have configuration files that are managed separately from the build system. That's not a significant thing here. What's important here is that we provide the options, whatever the mechanism of application. That's the core point we're trying to get to here. Since the DevOps engineer is presumed to be a subject matter expert in how the build system works and how the tools within it are being utilized, so long as we provide the tool option list and the contextual information about the tool and the element to which it needs to be applied, there's sufficient data to perform this activity. It's presumed that before deploying the changes, that the DevOps SME will verify that the changes to the settings do not break the build. The final step in this activity is the generation of the Security Options Application report. This requirement is one of the greatest sources of confusion in this activity. So let's talk about that. There are two motivations for the report generation exercise. The first is, unsurprisingly, one of traceability. We want to be able to show that we've applied the specified settings. This shouldn't require anything outside of the normal settings report that one would produce in order to present in a regulatory context. The second is settings enforcement. This treats the human-readable form as a helper document. We want to ensure that once we've made these settings and established part of the build, that they don't get changed. This provides us with a document that we can use for reference. It says, these are the settings that should be there. Let's check to see if that's the case. Many of you are thinking, can't we just tell people to look at the build file? It's self-documenting. For those operating in non-regulated industries, this aspect of the apply options activity is probably one you can skip. For everyone else, keep in mind that having a report in the DMS avoids the data extraction issues that come into play when there's a problem 5 or 10 years in the future requiring a review of the cybersecurity settings. If the build process includes a step which generates a human-readable form documenting the settings information, then this is easily recorded in the DMS. This report would be part of the product build documentation. Should a problem arise in the future, no one needs to stand up the source control and build systems necessary to extract and report this information. This step is fundamentally about future-proofing. Then that covers the final activity in the secure settings process. Let's look at some takeaways. This activity is probably the most straightforward one out of all of the secure settings activities. It consists of applying the settings to the build, verifying the build before deploying it, and finally creating a human-readable report for the purposes of traceability and also to later ensure that the settings stick. The materials that were used to cover this example are in the location shown here. It's important to note that the workbook includes all of the sheets covered in this training. For additional information and to get a more in-depth set of references, the Secure Settings Apply Options Procedure tertiary document is available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the secure settings process activities, you can proceed to the other training at this level, Secure Design Review. Additionally, if you've completed threat prioritization, you can also proceed to attack surface analysis, threat modeling, penetration testing, and vulnerability identification. Additionally, you can proceed to either code reuse or secure coding. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL Git repository.